Let's have another example where the root we are looking for is also negative. Welcome to Numerical Solutions to C Problems. Roots are x-intercepts, so they differ from solutions. From the name itself, one only needs to determine the approximate root by using intervals. These intervals are identified by purely guessing. The function for this example involves 2x cubed minus 2x plus 2 all over 4x raised to 5 minus 1. The root is still nearest the origin, and we are to take a negative root. Work until there is 4 decimals accuracy, and use initial values which are whole numbers. When looking for the initial values, note that the assumed roots should be near 0 and should also be negative. So we can start with x equal to 0, where the function becomes 2 times 0 cubed minus 2 times 0 plus 2 all over the quantity of 4 times 0 raised to 5 minus 1. The result is negative 2. Then assume a negative value. Take x as equal to negative 1. Plug this into the equation and find twice of negative 1 cubed minus twice of negative 1 plus 2 all over the binomial with 4 times negative 1 raised to 5 minus 1. The result of which is negative 0.4. Checking the trend of f of x, there is a negative root because from negative 2, we reached negative 4. So a little further the negative number line, we might have a positive f of x. Let's try negative 2, making the function 2 times negative 2 cubed minus 2 of negative 2 plus 2 all upon the quantity of 4 times negative 2 raised to 5 minus 1, giving positive 0.077519. With a sign jump from negative to positive, we can say that the root is somewhere within negative 1 to negative 2. To illustrate, we graph the points. So from negative side of the number line, we have a point when x is negative 1, where its y is negative 0.4. When x is negative 2, y is positive 0.077519. Let's join the points, assuming the curve to concave downwards. This is because we don't have any other points plotted within the range. From our assumption, the root is nearer x of negative 2. So the interval we take is from negative 2. We start the incremental search using intervals of 0.2 from the span of negative 1 to negative 2. We use the lower interval negative 2 and from here add the increment making x of negative 1.8. The function then is 2 of negative 1.8 cubed minus twice of negative 1.8 plus 2 all upon 4 of negative 1.8 raised to 5 minus 1. And that is equal to 0.07182. The result is still positive, so take another increment. So the function then will be twice of negative 1.6 cubed minus twice of negative 1.6 plus 2 all over 4 of negative 1.6 raised to 5 minus 1, giving positive 0.069674. Let's try a little further up the number line. Add negative 1.4 to the function, making 2 times negative 1.4 cubed minus 2 times negative 1.4 plus 2 all over the binomial of 4 times negative 1.4 raised to 5 minus 1, which gives positive 0.030560. Still a positive but near zero. Try the next interval and place it in the function. So we get twice of negative 1.2 cubed minus twice of negative 1.2 plus 2 all over the quantity of 4 of negative 1.2 raised to 5 minus 1, which gives negative 0.086184. Finally, we reach the sign jump, although note that we had started with the wrong limit. Let's explain this using the illustration. The assumed curve shows that the root is near negative 2, but when we iterated, the assumed root is nearer negative 1. So the curve is actually not what we assumed. Let's get more accurate with the root by using a smaller interval of 0.02 from the span of negative 1.2 to negative 1.4, and we will refer the iteration from negative 1.4. Add the increments as we are using the lower limit, so take x of negative 1.38. The function then becomes 2 of negative 1.38 cubed minus 2 times negative 1.38 plus 2, divided by 4 times negative 1.38 raised to 5 minus 1, simplified as 0.023604. The next iteration uses negative 1.36. Plug this into the equation and have 2 times negative 1.36 cubed minus 2 times negative 1.36 plus 2 all over 4 of negative 1.36 raised to 5 minus 1, which results to 0.015854. Still a positive. So try another increment where the function becomes 2 times negative 1.34 cubed minus 2 times negative 1.34 plus 2, divided by the binomial of 4 times negative 1.34 raised to 5 minus 2, which gives 0.007232. There are 2 zero decimal places now, so we are near 0. Try another increment. This time, it's negative 1.32. If we plug this value into the function, the result is negative 0.002353. Finally, there is a negative, showing the sign jump, but still only with 2 decimal zeros. Nearer 0, we will use x of negative 1.32 in the next increment. With the next smaller span, from negative 1.32 down to negative 1.34, we use intervals of 0.002. From the upper limit of negative 1.32, subtract an increment and make the function 2 times negative 1.322 cubed minus 2 times negative 1.322 plus 2 all upon 4 of negative 1.322 raised to 5 minus 1, which results to negative 0.001348. Let's look for a positive function, so subtract another increment and get negative 1.324 into the function to have f of x as negative 0.000354. There are more zeros now, but with insufficient accuracy still. So take another increment and plug negative 1.326 into the function, having twice of negative 1.326 cubed minus 2 times of negative 1.326 plus 2, divided by 4 times negative 1.326 raised to 5 minus 1, which yields 0.000629. We finally have a positive function, so no need to iterate further. For the next iteration, we start with the upper limit of x as negative 1.324. Having a smaller interval, we use increments of 0.0002 and starting with the upper limit of x as equal to negative 1.324. We begin the iteration of negative 1.3242. The function then becomes twice of negative 1.3242 cubed minus twice of negative 1.3242 plus 2 with a denominator of 4 times negative 1.3242 raised to 5 minus 1, giving the function equal to negative 0.001348. Work on another increment with the function having 2 of negative 1.3244 cubed minus twice of negative 1.3244 plus 2 all over 4 of negative 1.3244 raised to 5 minus 1, which is equal to negative 0.000157. The next iteration makes the function 2 times negative 1.3246 cubed minus 2 of negative 1.3246 plus 2 divided by 4 times negative 1.3246 raised to 5 minus 1, where the result is negative 0.000058. The next plugs in negative 1.3248 into the function, so the result is 0.000040. There are many zeros in f of x now, but let's validate our hypothesis. Work on another interval, making 2 of negative 1.325 cubed minus 2 times negative 1.325 plus 2 all upon 4 times negative 1.325 raised to 5 minus 1. This gives 0.000139. As observed, the result shows a larger gap, so we stick with the previous iterations. From the first option, 0.000058 can be rounded up to 0.0001, which then does not show 4 decimal zeros. The other option will be rounded down to 0. So we can then conclude that x is negative 1.3248.